All right, let's jump right in. Welcome to this explainer, where we're going to act as cyber investigators to explore the incredible power and, frankly, the hidden dangers of the archived web. Whether you've got years of technical experience under your belt or you're just starting to explore the digital landscape, we are going to build your understanding of this from the ground up. Today, we're diving deep into the tools and techniques used to research historical web content. So let's start by confronting a pretty provocative concept, one that challenges basically everything you might assume about digital privacy. When you hit delete on a public post, or say a company takes down a highly controversial web page, does it actually disappear? For a lot of people, the assumption is just yes, out of sight, out of mind, right? Well, as we'll see, the internet has a truly formidable memory. Here is our roadmap for today's explainer. We'll start with the foundations of OSINT, move into the reconnaissance phase, explore the digital time machine, identify digital footprints, and finally, look at counteracting information links. Section 1, the foundations of OSINT, uncovering the building blocks. Let's start with first principles. We need to look at how researchers, journalists, and even threat actors actually view public information. The term you're going to hear constantly in this field is OSINT, which stands for Open Source Intelligence. Now, the crucial point here is understanding what OSINT actually is. It's not just stumbling upon a random website or doing a quick Google search. It is a highly structured intelligence lifecycle. Practitioners plan their objectives, they collect data from diverse public sources like search engines, social media, and public records, and then they systematically process and analyze that information. And that brings us to a crucial distinction we have to make right from the jump: open source data versus open source intelligence. Open source data is really just the raw, unrefined material out there on the web. It's a random tweet, a standalone IP address, or a public business record. Open source intelligence is what that raw data becomes after it's been properly analyzed and put into context. Data is really just data until you analyze it to accomplish a meaningful task. Just look at this framework. When you see this, you immediately realize the sheer, overwhelming volume of public data vectors available to us. This is a visual map that investigators use to classify their tools. It branches out to help researchers search for dozens of specific target objects. We're talking about mapping out usernames, domain names, IP addresses, digital currency, the whole shebang. It perfectly visualizes how one simple piece of raw data can branch into this massive web of intelligence. Moving on to Section 2. The reconnaissance phase, mapping the invisible target. This foundational knowledge builds directly into the reconnaissance phase. This is actually the very first step in the MITRE attack matrix, which is a globally recognized framework we use to understand adversary tactics. During this phase, automated tools are deployed to quietly map an organization's footprint. Basically, investigators and attackers want to see what an organization looks like from the outside looking in. They actively scan IP address blocks to find open ports, they analyze domain names, and crucially, they're constantly searching open websites and databases to collect exposed employee names, emails, and even compromised credentials. To find these leaks, security teams use some highly specific services. Take Have I Been Pwned, for instance. It's a really powerful OSINT tool that exposes the severity of data breaches. You can quickly check if employee email addresses or passwords have surfaced in known stolen databases. Finding an exposed credential here is huge. It provides a massive clue for an investigator or a potential initial access point for a threat actor. Which brings us to Section 3, the digital time machine, bypassing the delete button. So what happens if an organization or just an individual realizes they've exposed something sensitive and they try to hide their tracks by removing the data? Well, this quote really hits the nail on the head regarding why web archiving is so critical. An archive isn't a live website. It's a preserved snapshot of how a page looked at a specific moment in time. Because websites constantly change, update, or just disappear completely, whether that's due to a server crash, a rebranding, or an intentional deletion to hide evidence, these historical caches are indispensable. They literally act as digital time machines, preserving information long after the original host clicked delete. To travel back in time, investigators rely on a specific arsenal of archival tools. The most famous, of course, is the Wayback Machine, which holds hundreds of billions of historical snapshots. Then you have archive.is, which is fantastic for manually creating snapshots of dynamic content today for future reference. There are also localized archives like the Portuguese Web Archive, which might catch regional things the global tools miss. And we also have to differentiate between browser caches, which just live locally on your personal computer, and search engine caches, like those from Bing or Yandex, which hold temporary public snapshots of recently changed pages before they get completely updated in the search index. While the Wayback Machine is a public service, tools like ArchiveBox offer a self-hosted, all-in-one solution that investigators can use locally. It lets researchers automatically capture and save exact digital copies of target websites in multiple formats, like PDFs, screenshots, and raw HTML. This is absolutely vital for documenting an investigation because it proves a piece of evidence existed exactly as you captured it, even if the live site goes offline tomorrow. So, the takeaway here is this. When you click a link and get a 404 not found error, you don't just give up. To a novice, that's a dead end. But to an OSINT investigator, it simply means you need to go consult the archives. That missing page is literally just the starting line for a complete historical web reconstruction. Section 4. Identifying digital footprints. Unmasking hidden connections. Let's look at exactly how this archive data exposes digital footprints that site owners thought they had successfully scrubbed. On the left here, we see a current WHOS record for a domain. WHOS is just a public database tracking website owners. Notice how it's hidden behind a privacy service called WhoisGuard based out of Panama. If you only looked at the live web, your investigation would stop right there. But on the right, we pulled an archived historical snapshot of that exact same domain from before they purchased the privacy protection. Instantly, we unmask the owner's real name, their physical P.O. box in Oregon, their phone number, and their personal email address. And that's just one example. By comparing multiple archived versions of a site, you can completely reconstruct a website's history. Business intelligence teams use this to research company evolution or shifting product timelines. Journalists use it to uncover deleted government policy changes or retracted public announcements. But most importantly, it allows investigators to corroborate evidence across multiple, independent archive sources, verifying that a piece of information is actually authentic and historically accurate before using it in a cybersecurity audit or a legal proceeding. Section 5. Counteracting information leaks. Defending your digital perimeter. Having seen the immense power of these reconnaissance tools and digital time machines, we have to pivot to the defensive side. How do you stop this? The answer lies in proactive defense. Protecting assets from the inside out is just not enough anymore because OSINT gathers information completely outside your firewall. You absolutely have to step outside your own perimeter. To truly defend your organization, your internal security teams must use these exact same OSINT tools, scanning the public web and checking the archives to see what sensitive data your organization is passively leaking into the public domain. Based on those MITRE ATT&C principles we discussed earlier, organizations have to implement strict mitigation strategies to shrink their public footprint. First, they need to properly configure intrusion detection and prevention systems to spot automated scanning. They must constantly scan their own intranet for vulnerabilities before the attackers find them. Implementing multi-factor authentication, or MFA, is absolutely critical to render those leaked passwords we found on Have I Been Pwned totally useless. Furthermore, companies need to minimize how many login pages are exposed to the open internet, and most importantly, conduct ongoing training to teach employees how to filter what they post online, knowing it could be archived forever. Let's do a quick review. We've covered how the internet has an incredibly long memory, and how OSINT practitioners have the tools to dig up deleted history, reconstruct timelines, and bypass those privacy guards. As we wrap up this explainer, I want to leave you with a thought to carry into our next lesson, which will be on digital footprints and online identity research. Knowing that every public post, every exposed IP address, and every updated web page might be captured in a digital time machine forever, how secure is the information you published yesterday? Thanks for learning with us, and we'll see you in the next explainer.